We are now looking at section 4, which is all about rotations. I'm just going to kind of guide you through this a little bit. For this example, we want to do a 120 degree rotation of triangle ABC about P. And basically what you're going to do is rotate each point individually. And I'm going to show you how to rotate A. Okay. Then it just says repeat for B and C. But basically we're going to take A and we're going to rotate it 120 degrees, then rotate B 120 degrees, rotate C 120 degrees, and after that you just connect the dots. And it should again create an isometry so that both triangles are congruent. So the first step when we're doing this type of problem, we want to draw a segment to connect A and P, and again you'll do this once again for B and once again for C. So it would look something like this. Then what we want to do is get out our protractor and we're going to measure out 120 degrees. So we do that something like this. So we would take our protractor and we would have to probably draw a lot longer line because our protractor would be a bit bigger than this, but we would take our protractor and draw a line at 120 degrees here. Once we've done that, then what we want to do is make sure that AP and A prime P are going to be the same length. So what we do is we just measure out the distance from A to P and measure out the distance from A prime to P so that these two distances are the same. Now we know that A has been rotated 120 degrees. We're going to repeat that for B and C. So if we did that, repeating steps 1 through 3 for each vertex, it would look something like that. Again, I'll show you real quick just with B so that you can see what it would look like. So we would take, for example, B, and we would put our center there, and we would rotate it so that it matches up with B, and we would go 120 degrees here. And we would draw a line connecting these two and make sure that from P to B is the same as from P to B prime. We would also do the same thing for C. Oops, sorry. For C we would do the same thing. And we would move this so that it connects up with C, and then make sure that it's 120 degrees once again. And make sure that the distance from P to C prime is the same as the distance from P to C. Okay? And here's another one where we want to graph the quadrilateral. We want, let's see, these vertices, and then we're going to rotate it 270 degrees. And I believe they gave you some shortcuts for that. So in this case, we can use the coordinate rule for 270 degrees. Basically, there's an easy way to remember those, but the rule is AB becomes negative B comma A, and so if we're going around like this, we would just change the values for each of these, which means we flip them and make the negative, the y coordinate negative. And the reason for that is because if we were in the first quadrant, if we switched over here and switched down here, it would, and then switched one more time, every time we switch to a new quadrant we have to flip these around. So by the time we get to 270, we're now in a quadrant where x is positive and y is negative. So it goes, and we can talk about that afterwards, but it switches to B comma negative A because x is positive and y is negative here. So we would plot all of these points and all of the new points, and then we'd see that it's 270 degrees. And here's another one, again rotating 50 degrees around this point right here. It would look something like this. I'll show you again what that looks like. So we would take P here, and we're going to rotate so that we're at E, and then we want to do a 50-degree rotation. So we would go, oops, I don't have that quite right, sorry. Oh, come on. So we would rotate, I'm sorry. So the D and E match up, and then we would go so that P and E are matched up. And so then we would go to 50 degrees. There's 0 degrees all the way up to 50 degrees. Again, we would put a point here, draw a line here, and make sure that the distance from P to E is the same as the distance from P to E prime. And we would do that for each of the points. Okay? And we can go over it in class as well. And let me get rid of this. And that's basically what it would look like. So PE and PE prime would be equal. PD and PD prime would be equal. PF and PF prime would be equal there. And we want to rotate 90 degrees. In this case, if we go 90 degrees about the origin, it would look like A comma B. And this time when we flip it for 90 degrees, it would be negative B comma A. So J, which is at 3, 0, would then become J prime, which is 0 since it's a negative 0, and then 3. K would become from 4, 3, flipped around, K prime would become negative 3, 4. And then L, which is at 6, 0, would become L prime, which again we flip it, it becomes 0, 6. So we've got 0, 3, negative 3, 4, and 0, 6 here. And then you'd plot all 6 of those points. So it would look like that. Again, the new ones would be at 0, 3, 0, 6, and negative 3, 4. Okay, just like I said. Good? And I think I want to go over one more thing. So for a 90-degree rotation, A comma B would be negative B comma A. And the reason for that is if we went from the first to the second quadrant, these would flip, and X is negative in the second quadrant. For 180 degrees, and you want to write these down, A comma B becomes negative A, negative B. So we switch it back to what it was, and since in the third quadrant everything's negative, then X and Y are both negative. So 270, we've got A comma B becomes B comma negative A. And again, these are going to be the most common ones. 360, obviously, hopefully, would just be back to normal. So AB would be AB again, because 360 is a full circle. And that's it. That's all we have here. Thanks.